Hello friends, Jermaine here and welcome to this video. In today's package of the week, we'll be looking at the SourceGen package. What SourceGen does is it provides a couple of utilities for automatically generating code. And although SourceGen is mentioned a lot, the learning curve is a bit steep. So we're going to explore SourceGen and put some examples together. If this is your first time visiting the channel, hit the subscribe button and also hit the bell notification icon so you don't miss out on future videos demonstrating how you can build full stack applications with the Dart SDK. I've got an example project set up with two directories. We've got my generators. In this directory is where we'll be writing the business logic for doing code generation. And example usage is where we are going to be using our generator. Okay, so let's go into my generators. I've got my papspec.yaml file, and then I've added a dependency for SourceGen over here. And in fact, I've got this set up on GitHub under the starter branch, so you can pull down that branch and follow along with me as well if you need. Okay, so I am going to come to libsource, and I've created this file, infogenerator.dart. And in this file is a subclass created based on the generator class. So generator is one of the classes that come with the SourceGen package, and we would use that to write our business logic that will do the code generation. So generator has a generate method, and it gives us certain details about the file that this generator will be running on. So it's going to be a Dart file, but then we're given details about the file itself via the library and details about the current build. So what we're going to do is I'll get rid of this bit, and then I'll just return the string generated, and I'll wrap it in a comment and save that. And then next, what we need to do is to define a function that will instantiate this generator, and we'll come to mygenerators.dart. I've already imported infogenerator. This function returns a builder, and we'll call this function infogenerator builder. When this function gets invoked, it gives us the build options. So these are options that I'll be defining in the build.yaml file, and it's builder options. And in here, we're going to return what's known as a shared part builder, because the way this generation works is it'll create what's known as a part file, and then that part file will be linked to the originating Dart file that file was generated from. More on that later. Here we'll just instantiate our info generator, and this shared parts builder needs an ID, so we'll just call it info. I'll go ahead and save this file. And then next, what we need to do is to register our generator while passing in this function. So in my generators, I'll create a build.yaml file. I'll define a builders key. The name of our builder is infogenerator builder. Let's define the file we need to import. We define the function we need to run, infogenerator builder, and we'll set the auto apply option to dependents. We need to define our build extensions. The key will be the file we're going to be matching. Next is a list containing what's known as a part file. So this will be called info.part. And what a parts file is an intermediary file that gets created when this generator runs. So if you imagine that there are multiple generators that will be running, multiple part files will be created, and then each part file would have a part ID, which we've called info. And this name info is based on the part ID we've configured here. So just make sure they both match. Next, we want to build to source for now. And then we need to apply one of SourceGen's builder called combining builder, which will combine multiple part files into a single file. Now that's done, I am going to come to the example usage directory, and then in papspec.yaml file, I've added a dependency for my generators, and then I've specified the path. So we're essentially pulling this in as a package. In example usage, in order to test out this generator, I'm going to create a build.yaml file. To use this generator, we need to define what's known as a build target. Build targets allow us to configure a subset of files that our generators will be running on. Our target key, in this case, will be set to default, and then we'll configure our list of builders. And then the first builder we want is the info generator builder. And for now, let's set enabled to true. Also, let's set the files we want it to generate for. So in this case, we want to generate for files within the lib source directory. All right, so let's go ahead and try and run this. I'll cd into example usage, and then I'll do pub run build runner build. Okay, so our build run successfully. Oh, I forgot to do one thing. So in order to actually generate the final output, which is example.g.dart, we need to add this part directive at the top of the file. So initially it will be red because the file doesn't exist. But then once we run the build again and we look here, we see now the file has been created. If we look at example.g.dart, and then we see that this comment has been generated, which is what we specified in here. But also if we see here, we have our part file created here. So this is what it looks like. And then it will namespaces with that. So if we go ahead and create another generator, it will generate a separate part file. And that part file will be named example dot and whatever the part ID is, like what we've specified here, and so on and so forth. And then because we are using the combining builder, it will combine all the part files and then it will chuck it in example.g.dart. So essentially we'll have a comment for every separate generator that we produce. And the reason we're able to see this parts file is if we come to our build.yaml file under my generators, we set build to source as the value. But what we need to do is to set it to cache. So let me run the build again. We should now see that disappear. And then we should see example.g.dart. Okay, cool. Let's work on our generator a bit more. I'll close the rest of these files. But before we do, let's see what's in this file, which has got various declarations in here. So I've declared some variables and constants. I've got a function here, and then I've got a class declared here with some instance variables, a constructor, and some methods. What I want to do with this info generator is to print out certain details about this file. So for instance, let's say these declarations. We can return all the elements in our library, and then I'll run this code generation again. All right, so this is what we get. We get our variable declarations, and then our function, and then our class. All right, so because all elements gives us an iterable, we can loop over these. So to loop over these, I'm going to create a string buffer. And in here, I'll just return buffer to string. And between these, I'll do library to all elements. And we'll just say for each, we'll create a comment, a single line comment. And in here, we'll say for each of the elements, we want the display name. And then we can log stuff like, let's say the element source. And then we can log out the elements declaration. So let's see what that gives us. Okay, so if we look at this now, all right, so this is what we get. We get all our declarations, and here's the source full name, so the file it's in, and then the declaration. So for each of our variables, there is either a getter or either a setter, or there's both. So for instance, the Boolean, we have a getter and a setter because it's declared using the var keyword. So that means we can change the value at a later stage, but variables declared with constant final cannot be changed once they're set. And in fact, we can make this a bit more specific. So rather than just logging out all the elements, we can, for instance, do something like, I'll just comment that out. So we can say library.elements, and we can look for where the type of that matches a top level variable element. So this class is from the Dart Analyzer package, which is already available when you install SourceGen. So let's import that. Okay, so once that's imported, then we get access to these sort of classes. So we can log out, we can filter all our declarations based on the type. So some of the declarations are variables, some of the declarations are functions, and so on and so forth. So in here, we'll just do top level variable element. So we'll filter by that. And then for each of that element, we can display the element's name. We'll do element.kind.display name, for instance, and we can also do let's say enclosing element.display name. And let's see what that gives us. Okay. And if we look at our example, g.dart, this is what we get. I meant to do declaration rather. So if I go ahead and generate it quickly, then we get that. We get the actual type and then the name of the variable. We can also dive into classes and be able to read certain information about it. I am going to create another generator. So I'll close this one and I'll call it class extras generator. I'll have the same imports as info generator. I'll create a class called class extras generator. And then in here, I'll create a buffer. And then in here to loop over our classes, I'll create a for loop. And then in here, we can do something like class.displayName. To work with this, I'll come over here and then I'll create a function for it. And then the part ID here, I'll call it fields. So from here, I'll come to our build.yaml file. We need to register that class extras generator. Most of the details will be the same as this one. Do that. And let's put that here. And then the part ID is fields. That's what we called it. And everything else pretty much remains the same. So I'll save this. And then in our build.yaml file, we'll copy this and define a target based on the class extras generator builder. Okay, so if I go ahead and run the build process, in our generated code, we see the part for our class extras generators over here. So if I go back to the build.yaml file, my generators, and I set these two to source, and I run this now, you can see why we need to define these part IDs, because that results in different part files that get created. So we can see these part files. So this is for the class extras, and then this is for the info.g.part, and then these two get combined into that. So that's why we need to specify this as the part ID. All right, let me reset this option to cache, and let's do a bit more with this. Actually, I'm not going to need element. Okay, so for each of our class, we are overriding the toString method, and that just prints out this string, including the fields in our order. Why don't we auto-generate this for us based on the fields? I'll start by creating a comment, and this is what we want. So I'm going to create a method called details, and then in this details would have this created as the output. And the way we're actually going to do this is through extension methods. So we'll create something along the lines of that. We are going to use extension methods to extend the order class by adding this method, which will produce this for us. I'll create a variable called name, and then I'll have the class display name, because we're going to be referencing that quite a bit. So let's start by creating this part of the code generation. So we'll do buffer.writeLine extension, and then we want a dollar symbol. So I'm going to escape this one because we want to print out the literal dollar string. And then in here, using interpolation, we'll have the class name as such, and we'll say on $name, which is our order class, and we'll have the opening curly brackets, and then let's close it off. In between these two, let's have a check that our class fields are not empty. If they're not empty, then we'll do buffer.write. So the main difference between writeLine and write is writeLine, that's the same as write, but then it adds a line break at the very end. We don't need a line break for this one, so I'll just use the write method, and I'll do string details. So we're doing this bit, so I can copy that, and then I can paste that here as such. And then we'll map over the fields And then for each of the field, we want to return a string containing the field's display name, followed by the equals symbol, and then the literal dollar, and then the field display name. So we are doing this bit. Then from that, we can write out to the buffer. I'll do that. Then have the class name. So we're doing this bit now. And then it will be followed by our field with values. But then in here, I want to do a dot join. And then we are going to join with a comma. And then let's not forget, we need that in a single quote. And then we need a semicolon as well. So let's save this. And then let's run our build again. All right. So if we look at our example g.dart, then now we get this generated with our order ID, order name, and even the hash code, which we don't want hash code. In fact, let's filter out this by doing .where field .display name is not equal to hash code. Of course, we don't want hash code to be included. So let's run this build again and let's see what that gives us. Okay, so now we just get ID and name. We can use this now. If we come to example.dart, and rather than doing this, we can delete that, and then we'll invoke our details method, which is an extension on order. And in fact, we'll test this later on. So watch till the end. Another of the benefit of this approach is if we go ahead and add another instance variable as such, then we don't need to modify this toString method because it will be generated automatically for us. So I'll run the build again. That should be auto-generated now as part of this details method. And if we come here, we can see in our details, we have price. Okay, so let's try and auto-generate this operator override implementation. So it will be of type bool, and then we'll call it compare. This takes in an object called other. And here we'll have this check. I'll create a final variable. I'll loop over each of the fields. For each of the field, we'll do field.displayName equals other, followed by a period. And then using interpolation, we'll say field.displayName. So this part is for this bit. Once we've mapped over that, we'll write this bit, and then we can still use our name variable, which is the name of the class. And then we'll just do field with comparisons dot join. And we are going to join using the double ampersand. So if we save that, and make sure you end it in a semicolon, or else in the generated code, you get an error. So whenever Dart generates the code, it also analyzes it to ensure that it's following the Dart conventions. So I'll save this. Let's run our generation. Okay, now we have our compare extension method. So we'll come to example. We'll just do like so. And then lastly, we can also auto-generate this bit. And we want something that looks like so, similar to the first two. I'll create a variable called field with hash code. We'll map over the field, and then we'll just return the field's hash code. We'll write to our buffer. We'll do fields with hashcode.join. Then we'll specify the plus. And let's not forget the semicolon. And that should be it. So let's go ahead and run our build again. And then we have that here. We will invoke the calculate hash method. We should be able to test this out now. I'll come to the bin directory. We have an example usage.dart file in here. We can test it out. I'll create an order object, specify my ID, the name of the order, and then the price. And let's print out order. Okay, so our toString method gets invoked and it gives us that. So that works. Also, let's test out our double equals operator override. And then to do that, I'll create two orders and then I'll compare both of them. Okay, so that gives us true. If we change this to 3, then that gives us false. Okay, let me revert that. So far, we've been generating code based on the generator class. There's also another class SourceGen provides called generator for annotation. And before we delve into that, This is the Json Serializable package, which uses the Dart build system behind the scenes to allow serialization of your class as a JSON string. So with this example, you would use this annotation to annotate your class and pass in a couple of options, and then it will generate two methods, person from JSON and person to JSON. Although the methods are auto-generated, we still need to manually create this boilerplate in order for us to make use of the auto-generated functions. So I came across this video by Philip of the Flutter team. He made a good suggestion. So rather than having to do this manually, we can write a generator that will automatically generate the from JSON and to JSON methods for us, which will use the auto-generated code by the third-party library Json Serializable. So let's take a look at how we'll be able to do this. I'll create a new generator. We'll call it Serialize Generator. Oh wait, but first we need to install the Json Serializable package, and then we'll run pubget to update dependencies. Then I'll import the relevant dependencies we need, including the JSON annotation library, which comes from that Json Serializable package we just installed. Let's create a class, and we want to extend generator for annotation. And then the type we want to target is Json Serializable. And then we need to override the generate for annotated element method. And in here, we'll create a buffer. And then the final output, it'll look like that. I'll create a variable containing the class name. Let's write out our first line. We'll have the class name, and then we want it to be on the class name. And then let's close it off. And then let's write our static method. We'll pass in the class name, and then it's the from JSON, and then have the underscore. We'll have the class name from JSON. Then we'll have our JSON passed in. Then I'll close it off, and let's generate our second method. I will have this bit as such. So that should be good. So I can save this. Next, we need to instantiate this generator, and the part ID will be called serialize. Next, we need to register our generator. Then we'll specify the name, such, and then the part ID is serialize. So now to use our generator, I'll come to example usage in the build.yaml file. We'll have our builder here. And we also need to add a dependency for the JSON serializable package. So in the pubspec.yaml file, I'll add a dependency here for it and just ensure that it's installed. So now we should be able to come to our example.dart file, import the JSON annotation library, and then we'll use our annotation here. So if we go ahead and we run the generation, we see in the output what's been generated from the JSON serializable package. So this is that third-party package we imported. However, here is our serialized generator that has been generated for us. The configuration we've passed in here can also be accessible in our generator. We can print out the value of that nullable option. So we do annotation.read, and then we are reading the nullable field. Because it's a boolean, we need to do bool value, and I'll save that. And let's run our build one more time. And in the final output, we come here and we see we get the value we passed in, which was false. Finally, let's make use of what we just generated. I can do order to copy dot, and we get the toJSON method that we auto-generated. Alternatively, we can use the name of our extension and then invoke toJSON. So let's print this out. So there we go. And then we also generated the from JSON method. So let's do that. From JSON is a static method with these options. And then we can print out order 3. So if I go ahead and run this again, then we get our third order as a JSON map. All right, this brings me to the end of the video. If you enjoyed it, give it a thumbs up. If you're not a subscriber, hit the subscribe button. and hit the bell notification icon next to the subscribe button so you don't miss out on any updates. If you've got any questions about this, let me know down in the comments below, and I will see you in the next one. Thank you.